Hi. As you know, I'm Emma White with Reading Across the Disciplines, and today we are lucky enough to have Amiraslani with us. He is a math faculty here at Maui College. Amir, maybe you could tell us a little bit about some of the classes you teach.
Sure. First of all, thanks for having me. RAD is a great program and it helped me a lot in my teaching. I teach a variety of courses here. I've taught at least once Math 82 pre-college math, all the way to Calculus 4 this semester. So everything in between, like college algebra, statistics, Calculus 1, 2, and 3, as well as trigonometry. So I've been involved in, and of course, engineering calculus to our ET program students. So a variety of math courses.
Huge variety.
Yeah.
Okay. Maybe you could tell us a little bit about some of the challenges you've seen with your students and reading.
Well, see, in mathematics, reading and writing should go hand in hand. You cannot just read mathematics without writing, and vice versa. You cannot just write without having the background and reading stuff. In my opinion, the most important thing in mathematics is being able to relate that to your fields of interest, your discipline. And you want to look at it as a process. You start with reading to learn to get to make yourself familiar with the content. Then practice. Practice cannot happen just through reading. It has to also include writing, looking at applications, going over examples. But of course, going over those examples will imply that you should read more and go back and study. And then, of course, try to apply that to as many real life or discipline-based situations as possible. And then think of it this way. The end goal may be that at some point you want to report back to some lay audience. And you want them to be able to read the results of your work. So to many of them, your formulas may not make sense. But the way you write your report, the way you want to explain it to them will be important. So not only should you read for you to learn and understand mathematics, you should be able to write the results such that other people can read the results easily.
So I see that you've got this sort of bringing the reading to life.
Yes.
And that it's not just on the page. It happens in a lot of different ways.
Exactly.
Maybe you could share with us a technique that you share with your students to help them understand that concept or apply that in the way that they do their reading.
In many cases, I assign real life projects. I'm trying to incorporate some project-based, problem-based learning techniques in my teaching to make math more fun, for one thing, and maybe at least some of my students will become interested in the topic, and that interest will lead to going further in mathematics and in their own disciplines. So when I assign the projects, they are supposed to, for example, collect data information that will happen through reading. Then they want to analyze the information and answer the questions depending on what the project, what the problem is. Again, reading as well as writing, reading about the topic, becoming familiar with the details of the topic, and then they do the work. For example, in my statistics course, I want them to give a survey. They should know how to prepare a survey, then how to conduct the survey effectively. And then, more importantly, when they have all the data, all the samples, they want to come up with a hypothesis. And they want to use the knowledge, which, of course, for that, they need to go back to the textbook, for example, or other resources, read, study, practice, and apply their knowledge to their own collected data from the samples, and then test the hypothesis, like I said. So, and then, of course, once they're done, they want to write a report that is easily readable for the audience. So again, I see a loop here, starting with reading, ending with reading. The beginning is the students reading, the end is the audience whoever the reader is, they want to read the report and be able to make sense of it. So what happens in the project and in this process overall involves a lot of reading and writing and practice. So hopefully they learn mathematics through this process and become interested in the subject, not only math, but the subject of their survey or project, whatever.
Well, with your focus on relevance, I'm sure that that's happening, that real-world focus. And from an engineering and a math perspective, you've read a lot yourself, and I'm sure, as we all have, we've all had struggles and gotten through courses where we thought that the reading was really impenetrable. What was a way that maybe you yourself or something that you share with others about making sense of engineering and math textbooks? What's a technique you find important?
One of the most important things, and I guess it's totally relevant to your program, RAD, is annotation. Because, and we had many instructors telling us that if you haven't basically made the paper you're reading dirty with all the annotations and things like that, you haven't effectively read that yet. You have to pause, think about what you've read, paraphrase that, come up with formulas related to that, make it some sort of a practice session for you, and do not go further unless you know what has happened already. Because if you have questions, of course, you can jot down the questions and ask your instructor or your co-workers if you're conducting a research. But one way or the other, you don't want to miss any part. You want to be able at the end of the day to make sense of the entire paper or book or whatever you're reading. That's both important for learning and if you want to conduct research and if you want to, of course, if you're working on a project, job-related project later on.
If a faculty member was struggling with encouraging annotation in the classroom, what might you recommend to them to get their students to annotate?
See, a well-designed project could help. So you want to define the project, at least give some information about the project and have them go and do some literature survey. And occasionally, of course, I know it's impossible in many cases to be able to oversee the entire process because of time limitation and other things. But you want to make sure that at least a couple of times, if not more, they come to your office and run the project or where they are by you, so you know they are on the right track, and then give them clues and hints, and this way you can have them actually annotate, write down things, if necessary use different resources if they are not using correct resources. And of course, most importantly, you want to check whether what they're doing is aligned with the course content itself. So the most important reference would be the book or textbook or whatever the resources you have provided to them. So you want them to go back and compare what they've been doing with what they have seen in your course and the textbook and make sure that everything checks. If not, then either you can help them or it's a good learning process for them to go and find what the problem has been.
So using their annotations or expecting them to bring in their annotations to you as sort of artifacts to understand their thought processes and then using that as a way to give them feedback almost.
Yes, feedback is very important, and I don't know what they've been doing if I don't see their at least scrap paper work or annotation or whatever they have at that point. Yes,
that's a really interesting point, because I think sometimes our students feel like that's the sort of refuse or the trash that we don't, but really that's the stuff we want to see.
Yes, yes.
The stuff that shows that they're getting in there, and as you said, getting messy with the material.
Yes, and of course at the end of the day they want to be able to polish the work and come up with a neat and so again, that's important. You want to have all these things in the background.
The steps.
Yes, steps. And I want them actually, in many cases, I don't want them to include all the details because sometimes it's boring for presentation or for reports to the readers or the audience. But for them, it's very important to have all the steps somewhere written. And just like lecture notes of the course, I definitely ask them when they're taking, for example, college algebra or pre-calculus or trigonometry, I want them to keep the notes or resources, because later chances are they will need some of the topics, if not all of them. The same is true about annotation. They may find really important and interesting facts that they do not know, may not know exactly at that point, but later on they're working on another topic, another project. It happens to them that, oh, we've seen this doing that project. And if they have the annotations and everything, all the details, they can easily go back, and it will make things even more interesting to them, and hopefully they will become more interested in the subject.
It's the spider web.
Yeah.
And just one last quick question. How has RAD affected your teaching?
The most important effect of RAD was it helped me, because I was sort of on the fence but how and whether or not to incorporate project-based and problem-based learning in my teaching. And RAD really helped me decide, and my decision was, yes, let's go for it. Let's at least, as of right now, it's 10% of the entire coursework and score. And it's good, it's reasonable for now. But at least there is a component of problem-based learning in that, which will make them read beyond what, I mean, yes, I could have given them just homework assignments, midterm, final, and that's it. But maybe not for all of them, at least a portion of them, a percentage of them will become interested in a couple of topics to follow up later. And that will help both to learn and appreciate mathematics and their own disciplines or whatever they're interested in. So yes, RAD helped me introduce this project and problem component to my teaching. Excellent. Which I really appreciate.
Well, thank you. We really appreciate you.
Oh, thank you for having me.
Thanks, everybody.
Thank you.